Hey, Math 098, we are doing Chapter 8, Section 2. I shared with you the reason why the quadratic formula is what it is through a Khan Academy video that uses completing the square to get the answer. Now, you don't need to know how to do that. I just shared it. I don't know if you've ever seen that before. Otherwise, just go ahead and memorize the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now make sure that you understand what a, b, and c stand for. It is in the form ax squared plus bx plus c is equal to 0 because the quadratic formula finds the zeros or the x-intercepts of a quadratic function. And by the way, the x-intercepts are called roots or zeros if you're using a graphing calculator. So as we use the quadratic formula, I do want answers in simplest radical form because I don't want you to use a graphing calculator and just write down the decimals. So make sure that you understand that a is 3 in this problem, b is negative 5, and c is negative 2. So when we go to the quadratic formula, we get negative b, so positive 5, plus or minus the square root of negative 5, once you square it, is positive 25, minus 4 times 3 times negative 2, all over 2 times your a value, which is 3. So you're free to use a calculator. I don't mind that you use a calculator to simplify. For instance, well, you want to make sure that you're doing in simplest radical form, so you can write what's under the radical first. 4 times 3 times negative 2. So you get 49 there. And I would anticipate you know that plus or minus the square root of 49 would give you 7 all over 6. So you do get two answers. You get 5 plus 7, which is 12 divided by 6 is 2. But you also get 5 minus 7, which is negative 2 divided by 6, which would reduce to negative 1/3. So these are the two answers for x in this problem. So this worked out really nicely to get exact values, whereas if you were to go to a graphing calculator and type in, let me clear all this out for you, 3x squared minus 5x minus 2. Let me hit zoom 6. And I think it's pretty clear that it's crossing the x-axis at x equals 2. This other one might not be as obvious, so let me show you how you can figure that out. You hit second, trace. It's called a 0 for a reason. They don't call them x-intercepts here. They're where the y value equals 0. And what you have to do is move your cursor to the left of your x-intercept. So anywhere to the left of this x-intercept, hit enter. Anywhere to the right of your x-intercept, so it's right bound there, hit enter. And then somewhere in between, hit enter. And this as a fraction would be negative 1/3. So you can double check your answer that way. And just like with points of intersection, you can only find one at a time. So if you hit second, trace, option 2. So this time a left bound, hit enter to the left. This time it's below. A right bound's on the above, and then best guess, you will get x equals 2 on that one. So you can use a graphing calculator. I just don't want to see rounded answers. As you notice the next one, it's very important that they have to be equal to 0 before you start labeling things. Because I've had students in the past say a equals 3, b equals negative 8, and c equals 2. Wrong. You have to rewrite it to equal 0, so then you can go through and say, okay, a equals 3, b equals negative 8, and c equals negative 2. So when you go to the quadratic formula, x equals negative b plus or minus the square root 64 minus 4 times 3 times negative 2 all over 2 times 3. So what I want to see is, because this one's not going to be a perfect answer, but go ahead and use your calculator. 64 minus 4 times 3 times negative 2. You get 88. But what I would like to see is that you break down 88. Let's see, 8 and 11, but I guess what I'm doing in my head is breaking down. I guess I can do this off to the side. We got 88, but I'd like to see you break it down, 8 and 11, 2 and 4, 2 and 2. So the square root of 88 is equal to 2 square root 22, because there's one pair of 2's and all of the other leftovers get multiplied. So the answer I would like to see is x equals 8 plus or minus 2 root 22 all over 6. And I'm going to let you leave your answer like this, although I do want to point out that a better math teacher or the back of the book would divide all of these whole pieces, not the radical. All of those are divisible by the same number. They're all divisible by 2. So you'll see in the back of the book, 8 divided by 2 is 4, 2 divided by 2 is 1. Leave the radical alone, don't mess with that. And 6 divided by 2 is 3. And you could check your answer using a graphic calculator, but again, I don't want to see the decimal answers unless they are perfect fractions. Hopefully that makes sense. If this is not making sense, please write down your questions, bring them to class, or email me and let me know so I can help you out. So as we look at the next one, we can deal with fractions, not a big deal. A is 1/4, B is -1, C is 1/2. And again, you might just need to go to a calculator to plug in. But it is -b plus or minus the square root of b squared minus 4 times A times C all over 2A. So, I think you guys could do this in your head. That 1/4 of 4 would cancel. So you have 1 minus 1/2 there. I just don't know how good you guys are with fractions. But as I'm looking at that, I'm seeing 1 plus or minus the square root of 1/2 all over 1/4 times 2 would be 1/2. Well, dividing by 2 is the same thing as multiplying by the reciprocal. So this is the same thing as, I'll go ahead and write it. 1 plus or minus, well, you could square root each piece. Square root of 1 is 1. This would be root 2. And instead of dividing by 1/2, I can multiply by 2. So as I distribute this in, we'll have 2 plus or minus 2 over root 2. I think I'll let you leave your answer not rationalized. But if you were to rationalize that denominator, the best answer would be 2 plus or minus root 2. Because as you rationalize that denominator, you would have 2 root 2 over 2, and then the 2's would cancel. So this is an acceptable answer as well. I want to stay away from you guys using the graphing calculator to give you decimal answers. I'd rather see exact answers that are not completely simplified. Okay, and again, if you're confused by what I mean by that, please email me or write down your question and bring it to me so I can address it. So notice an issue with the next one is it's not equal to 0. I like to have positive numbers whenever possible. So I would add 2x squared to the left side. Also notice that I'm trying to get it so the x squared is written first because it makes more sense to say a equals 2, b equals 1, and c equals 2 in the problem. So as we solve this, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So again, if you use a calculator, that's fine. But I don't think you really need it because 4 times 2 is 8 times 2 would be 16. We have 1 minus 16. Well, don't forget, we've actually worked with square roots of negative numbers in Chapter 7. So that's not a big deal. We just have I root 15 in that problem then. If you try to break down 15, well, there's no pairs. So we can just leave our answer as x equals negative 1 plus or minus I root 15 all over 4. And there's no reason to simplify that any further. Very good. Again, feel free to use a calculator, and I could easily make a typo in here as well. So if you see an error, feel free to bring it to my attention. Or write down any questions. The next piece that we're going to talk about is what's called the discriminant. And the discriminant is what's under the square root. So if you look back at your formula, the square root is that b squared minus 4ac piece. And it's all based off of the square root. So we have 3 options. We can either square root a positive number, we can square root a negative number, or we can square root 0. And that's why we're considering, the square root piece. The discriminant is only what's under the square root. So what it's basically boiling down to is if we're square rooting a positive, we have 2 answers, the plus and minus version of that. So that means there are 2 real solutions. In other words, there are 2 x-intercepts on the graph. Now, if we square root 0, yes, there is a plus or minus, but it's adding 0 or subtracting 0. So what's the difference between adding 0 and subtracting 0? You get the same answer. So therefore, there's 1 real solution. And what that means for that quadratic is it just touches the x-axis. It does not cross the x-axis, so that there's still 1 x-intercept. Whereas when we talk about a negative, well, that means that we're getting imaginary answers. So we have 2 imaginary, that's what we just found out, solutions. In other words, there are no x-intercepts. And I would encourage you to look at a graphing calculator to verify that. So as we look at this problem, A is 1, B is negative 6, and C is 9. Well, all we need to do in the quadratic formula is the square root piece. So B squared minus 4 times 1 times 9. Okay, well, 4 times 1 times 9 is 36. So that means we get an answer of 0. The discriminant equals 0. So what type of solutions and how many? We have 1 real solution. And you can look at the graph if you have the time to look that up. Whereas when we look at the next one, A is 1, B is negative 3, C is negative 1. And by the way, if I'm going too fast, feel free to write down every little step. Negative 3 squared minus 4 times 1 times negative 1. But don't forget, when you square a negative, you get a positive anyway. And then negative 4 times negative 1 makes it plus 4. I only care that it's a positive number. It's greater than 0. So there's 2 real solutions. There are 2 times it crosses the x-axis. Whereas when I look at this last one, and by the way, if there's no x value, that means b equals 0. So as I look at the discriminant, it's 0 squared minus 4 times 1 times 11. Oops, that should have said 7 there. 4 times 7, see? Mistake right there. I have no idea what that number is, but I know it's definitely smaller than 0. It's definitely a negative. I don't really feel like figuring that out, but you can. But what that tells me is that there are 2 imaginary solutions. There are no x-intercepts here. So I'm at my time limit on this. I don't have time to finish the notes in the next 10 seconds. you could try this assignment on your own, but I will make another video to finish exercise 6 and 7.